So what I'm going to have you do here in just a minute, on the back tables, I put out some big poster paper and some markers and some tape. But you don't need to all sit at the back tables. You could go and get supplies and bring it back to the front tables if you want. And I'm also going to bring you two things. You're going to get your sentence strips. I think I showed you guys these before. So you're getting like some beginnings of sentences, and then you're getting some connecting words like because. Okay, and then I'm also bringing you, I think I showed you this on Wednesday too. I'm also bringing you your instruction sheet that contains a bank of physics ideas and physics words. And then I think on Wednesday I explained like the sentence strips and this bank of ideas is maybe 10 or 15% of the words. But with your partner or your group, you're going to have to add in another 85 or 90% of the words to create some paragraphs out of all of these ideas where you're fully explaining Miss Stein, and in this case, in your sentences, it's all Mr. Little. You're fully explaining their rollerblading movements in the hallway now that you know a lot more physics. Like at the beginning when I had you explain that, you didn't know very much about Newton's laws.
I was wondering why you did it.
Yeah, like you just didn't know how to phrase it. You know, you didn't know what kind of laws to use, but now maybe you do and you can add that to your explanation now. So I'm giving you a little bit of help with the sentences and the idea bank, but a lot of this is going to have to be from your partner, and you can look back in your binder and stuff like that to try to create your posters. It might be smart, I saw some people in the other section doing this, it might be smart to like lay all the sentences out and look at the word bank and maybe start writing out like a little bit of a rough draft on your own paper before you tape anything down or use marker on your poster. Like it might be smart. And I also hope that you'll like argue a little bit with your partner.
Argue?
Okay,
Yes.
so I want you to say like, no, I don't think that goes there, I think it goes here. Okay, so I want you to disagree sometimes with your partner and have to argue it out. It's okay. Samson.
So we have to use all those words?
All of these plus your pink sentences, plus your own ideas.
So we're supposed to disagree?
Sometimes,
Is that just
and argue it out.
okay.
Ideas, I think. Okay, we should start with a topic sentence, which is okay. Actually, I don't know. You don't know what. Are we allowed to just make a whole sentence on our own?
Sure. Yeah.
You want to?
Have you looked at what all of these say?
Yeah, we
Yeah.
already did.
But yes, you can totally, in fact, you're probably going to have to add whole sentences that are just your own. And you'll have to, like, I've put in some vocabulary words, but I haven't put in any, like, fully explained ideas. So you'll have to do a lot of, like, explaining what your ideas are.
Okay.
Oh, add in speed.
Speed. What do you want to start with?
They force?
I don't know. Just
Topic since
Mr. Little started those. Mr. Little.
Hanad,
Moves on Warming.
this is two.
How do you want to start this? I don't
Those are all
know.
your
Really not
missing
any
things.
idea.
Write on a piece of paper. Like,
Yeah, but what do you think our topic sentence should be?
Mr. Little moves,
Mr. Little moves on rollerblades differently. I don't know. That doesn't sound good.
I don't know.
This is hard. You have anything else going on?
Wait.
But like we should explain what Mr. Little is doing. We should should do like watch Mr. Little
Then Mr. Little would glide down the whole glide until one foot and push off on another. Yeah. First, Mr. Little's at rest.
at rest, and he
First and because and no.
okay, this is at the end. Okay. At first, Mr. Little's at rest, and then he starts to have a gliding foot, which is saying well, what I'm trying to say is saying that you put more force on one leg to push back.
Skate and do a Sean. Skate and do a Sean.
And blow back like a
Are you ready for that one?
I was about to say he starts out slow, but if Mr. Little pushes against the floor, then
Okay,
Yeah, I
so
get
it
that.
sounds like you're saying that one goes you could have
Yeah.
words in there,
And
but then like that one, okay?
But if Mr. Little pushes against the floor, wait, what do you mean exactly when you push it?
Like what you were saying with the pushing foot,
Yeah, okay.
that's what I mean.
Okay, when he
Pushes on the floor.
If Mr. Little pushes against the floor, he starts to get faster. He starts to accelerate
Okay, then I would suggest,
because
so why does he start to accelerate?
the more force in this, should we say in the second law?
That would be great.
Yeah, because in the second law, the more force you put, would you say the more force you put, the more you accelerate?
Is that correct?
Because it's the second law. The more force you put, the more you accelerate. Right, so we're done
Okay,
with
so wait,
this one.
time out. Is there any becauses that you could do up here about at rest?
Rest, okay. Should we sit?
Or any for examples?
So you want me to read you what we have so far?
Okay, read.
At first, Mr. Little's at rest, and then he starts off with his gliding foot, which is putting more force on one leg and pushing backwards. He starts off slow, but if Mr. Little pushes against the floor, he starts to accelerate because in the second law, the more force you put, the more force you accelerate.
Pushes
The more you
against.
accelerate.
The more, yeah, okay, that's good.
So is there anything up here, like, because you jump straight from Mr. Little is at rest and then he starts pushing.
Do you want to
Is there
talk
anything that
about
you could explain
first
about
law?
at rest?
Because the first law is like where an object that is at rest stays at rest until it's able to move with a type of force, and an object in motion stays in
Yeah,
motion
so we can
unless
push
stopped.
that back.
push that
And then say
Okay, where?
addition.
Great.
Where? So
So like, in the arrow it would be before, but
like starts off with his gliding foot, which is putting more force on one leg and pushing backward. And then right here, should I start?
wait, where's the but? But okay, it's right here. So instead of this,
So cross this out right here.
no, we're gonna add something into this saying in addition in here.
Okay, so in the first law, an object at rest stays at rest until pushed with force, and an object at motion, an object in motion stays in motion unless stopped.
Oh, okay.
So put that right there.
Yeah, just put that right there. Should we say we know this because in the first law?
Should I put we know this because
After
in
you say that.
addition, okay, whatever.
Okay. In addition, in the first law.
Dude. Let's go brush that. Did you fire on it? That's the first part out. What?
In addition, we know that in the first law, an object at rest stays at rest until moved with force. An object in motion stays in motion until stopped.
Wait, did you say we know this?
We know.
Oh, okay, that's cool.
We know this.
First
Wait, I'm gonna write in.
And then we did that part, and then we did because, and then we should stop there, and then start about something else. Is Mr. Little carries a heavy backpack while he's skating?
Put that right there.
Should we start? Which one do you want to do? Okay, this one's gonna be last because it's when he stops. So that's last. And in order to keep himself,
Because in each sentence, should
what about this one?
for example, and a because.
For each one.
This shows that.
Okay. For this one?
For each sentence, or
Yeah, okay. For this one, we're gonna need more people. We have to talking about the more force you put, the more you accelerate, and we're trying to get him to a constant speed, so it wouldn't work. But then, what's the first law about? It's about
so when an object is at rest, it stays at rest until moved with force, like until like you push it or something. And then an object in motion stays in motion until stopped.
Alright, let's talk about the first one because like let's talk because like it goes back to that because like the more put a constant like force, don't put more force.
Okay, so in order to keep himself moving at a constant speed, he has to.
Oh yeah, we need more people. Alright.
Here you go.
Oh, perfect.
Does it bother you that it has wrinkles in it?
No.
Okay.
You
feel like you're starting to get it?
Uh-huh.
Okay, good.
And then for here we're gonna, in order to keep himself moving at a constant speed, he has to put like the same,
He has to keep switching between his legs back and forth.
like between his gliding legs.
Between his gliding leg and his pushing
leg.
Because?
Yeah, I know. We have to put a because in every one.
We have to put it because this shows that we know.
We know this.
So tell me, why does he have to keep switching feet? What's the physics behind why he has to keep switching feet?
Because if he was to just stay at like this, like standing, he wouldn't go anywhere. He would keep slowing down. But by switching feet, it keeps his motion or it keeps his speed up.
Okay, so why would he start slowing down if he stopped pushing?
Because there's no force and no
Wait, which force?
like there's no pushing force. And
Why else would he slow down?
because there's no motion like him moving, he's just
Can you help? Like, why would he, if he stopped with the pushing feet, why would he eventually slow down?
Because he can't go forever.
But why?
Because it's like the tension, like it's called the tension, like it will like keep you going, but like it'll stop you and stop.
What is that called, that thing that you're calling tension?
Tension? What's it called?
Use your word bank.
Oh yeah.
You can turn it upside down too.
Normal force.
Nope.
No.
Think about it. What is that with this when you're
Oh,
sliding?
less friction. Less friction. Okay.
Okay, so do we have to, because we already used this one right here. We already used inertia at rest and motion. And
We use acceleration.
acceleration. You check out the word.
Yeah, use your tools.
Okay. 'Cause I totally forgot.
Yep.
Okay. So we're about to use less friction. So what we should like.
So in order to
Would it be, you have less friction and you have more friction as a choice. Which way would it be?
What are you doing? Constant speed.
That Sydney was saying like he has to keep pushing
between his
with the foot because he'd start to slow down. And then you said he would start to slow down because of the tension, but what you really mean is friction. So which way is it? Is it that there would be more friction or less friction
There's more friction.
compared to his pushing, like since he wouldn't be having a pushing force?
Wait, wouldn't there be more friction to stop him?
Yeah.
So less friction helps you keep going, and more friction stops you.
Yeah.
Well, if there was less friction, like if there was ice.
Exactly what was on the thing. We were watching a video and it was metal, so the train would go on the metal, so there was no friction. So it wouldn't stop it down, so it'd go fast.
What video are you talking about?
We're talking about, I think it was Bob.
Oh, okay.
Yeah, Bob. I like him. Science guy. Bob, science guy. Yeah, we were watching. Okay. So the more friction is to stop him, and then the less friction is to keep. Oh,
Maybe you'll use less friction somewhere else, because you got a lot of sentences
Yeah.
still to go.
Okay, so in order to keep himself moving
Okay, you
at
guys sound like you're doing a good job.
constant speed, he
All right, so you're gonna rough draft it out. So have you looked through all of your pink slips? So you know what your tools give you already to work with? Okay, and so remember, like, you're telling me this story, but you're also adding some reasons why. You're also adding some evidence. Okay, so like instead of just like telling me the whole story, jump in and add some of these connector words too. And that's how you can supply your physics ideas. Okay? So let's start it off. So it's your first sentence is going to start with, at first Mr. Little is at rest and
Then we'll start moving, and then we're gonna, at this, but then we're gonna cross but if out.
okay. Okay, so you're going to cross out the but and it'll say then to start moving if Mr. Little pushes against the floor. What would you say? I mean, some of this is going to have to be your words. It's not going to be my words.
Then he will speed up.
How come? Because
The pushing force. Wait. The pushing between the floor and him makes
so there's pushing force.
the pushing force between the floor and Mr. Little makes him go faster because there's less friction when he's
As he pushes up.
gliding. I mean not gliding, when he's pushing off.
Okay, so this is why I think you guys should start writing a little rough draft on a piece of paper so that you can start keeping track of what your sentences are already saying and what kind of new sentences you might need before you put it on your poster. Okay? But I like what you just did where you used your like connecting words and you used your tools to try to like jog your memory of what kind of ideas should go in there. And don't forget you can use the Newton posters too as a tool if you need to like jog your memory about the laws. Okay? Got it? Okay.
Force towards him. It's like related to their law or something.
I think that would be great. And then that sounds like a perfect time to use for example.
Yeah. But for example, like.
For example, so we need to show an example with the meeting.
That would be great.
Like me, for example.
We'll do our karate kick one.
Oh yeah.
So what are you guys looking for?
we're looking for a poster that explains something about friction.
About friction? Yeah. I would guess probably your Newton's second law.
Oh, okay.
Or maybe the third law might also contain some friction ideas.
This is the third law right here.
Action.
So I would say like either these two posters or those two posters.
friction. Force that pushes an object negatively.
So friction pushing a object negatively, wouldn't that mean the other opposite way? Like this
Like
is
the other
positively
way?
and this is negative?
Correct.
Okay,
So like if the way he's moving is positive,
then he's gonna go backwards.
Then he's gonna go the opposite direction.
like if he's already moving
Then it's gonna slow
positive,
him down.
then the friction is like
Gonna
the
stop.
dragging on the
Yeah.
floor.
It's like the carpets.
Yes, it's exactly like the carpet.
All connects. Okay.
Shauna, what are you trying to figure out?
I was just like looking for this one because I don't really remember.
For the F equals MA? Yeah.
Here, let's look.
We might need that
So
one.
it should be, yeah. So force equals mass times acceleration. So what does that even mean? Do you remember?
Like you're speeding up.
Give me my hard work.
How much you're speeding up by the weight? Tell me more about that.
Like those things put together equals
So you're saying like the mass, what is it when it's saying the mass times the acceleration? Yes. Equals the force? What do you think that means?
Selena, I'm moving my pages.
Yeah, I was.
So we don't put like.
I remember it's red, black, and then.
I don't know how to explain.
Yeah, I know, it's a hard one. So what if Mr. Little wanted to accelerate even more? What would he have to do?
You would have to like push off like with his feet like more and more, so like his speed will
Okay, so in this formula, if you're saying to make his acceleration go up, would he have to add more to his own mass, or would he have to add more to the forces? So you're saying that to speed up his acceleration, he would have to also increase his force. Okay, now let's think about another case. What if his mass increased? Like, what if he was carrying a heavy
and
backpack?
he'd go slow.
So you're saying if his mass went up, his acceleration would go down? What would he have to do if he had on the heavy backpack? What would he have to do to, like, keep his acceleration up?
Like move rapidly.
So, like, maybe add more
Yeah.
force? So if he was heavier, he'd have to add more force to keep his acceleration the same? Okay, that's all it means. It's just a math way of saying all these ideas that you already know.
Okay.
Okay?
Part of the. And then we're gonna use the ice skating rink because it's like no friction.
Good. Remember that? Do you remember way back at the beginning when we were
yeah.
doing this? And you
I
kept
was
getting
like-
so stuck on the ice skating
I
thing?
was like, well, it wouldn't move, and you're
And you
like,
kept talking about
why?
tension.
I was like tension. You're like, why? I was like,
But now how do you feel?
it's because friction. It will stop you because the more there is, the slower you go because it'll go in your skates and go stop.
So, but now how do you feel? How do you feel about
I
the
feel
icy
good.
one and now you know what friction is?
Oh, we have icy systems.
Yeah.
Yeah. Do you feel like that you can now like imagine
I
what
can
it
do an
would be
essay all
like?
about it.
You could do an essay all about
Watch me do it for
rollerblading on
science.
ice.
I remember one day she'd always say why. That would be a hint.
I put that sentence in there just for you, the icy one, because I knew you'd be like, oh no, not the icy surface again.
Okay, so Helena, if Mr. Little starts pushing and just rolls on the floor,
It's okay. You can. If Sydney will move her feet, you can sit there.
There is, did I say it, less friction? He keeps on like,
so with less friction, he keeps going.
yeah, he keeps on going. And then you can say there's nothing to stop him.
Huh?
You can say there's nothing to
Because
stop
there's nothing to stop him.
But with less friction,
And then she wants to say
Yeah,
because.
I swear that word. Because there is nothing to stop him.
That kind of reminds me of, do you remember when Destiny was talking about at the roller skating rink? When you're like on the rink itself, you go pretty fast, but then if you leave, you know, and go to like where the arcade games are and stuff,
And
where
you
it's a
slow.
carpet,
You slow down. It's like you can't like.
Yeah.
I remember I fell like 5 times.
when you hit the carpet.
Yeah, I was all like,
because there's
Yeah.
like, it's like you're going so smoothly on the polished
Yeah,
floors, but then
you're
you're
so
on the
used to it.
bumpy surface.
Yeah,
Yeah, and there's more friction.
and now you could explain it like with physics.
Oh, this shows that.
Okay, get up. Oh, because is this no? This is
No, this shows that. Should we say again about the third law?
If you think it's a good example, like if it illustrates
Oh, what
law,
about
you should.
like skating rink? Like let's talk about skating rink. Like how?
Shouldn't that be
Do
like
you have any
another
more?
sentence with
Do you have any
for
more for
example?
examples?
Yeah.
Use it for example.
We don't have any more.
Or you could write it in.
Or what about like in addition?
Great.
And pushes against the floor. In order to keep himself moving at a constant speed, he uses his inertia or weight to excel himself. As he is in motion, he is using pushing force to overpower friction. As he pushes off
The horse pushes off
the floor to glide. The floor shoots an equal but opposite force towards him, which is the third law, and Newton's third law. For example, if a kid kicks a wall, the same force comes back at him and hurts him. As he glides through the hallway, his legs are using balance. His legs are using balanced forces, so they have the same velocity. As gravity pulls him to the floor, the ground pushes up, which is called normal force, or Fn. As he presses his feet against the ground, it makes more mass. And when he takes his foot off, it creates less mass.
Okay, so I think, wait, so you're saying that if he picks up his foot, he has less mass?
Like he uses less mass because more of his less of his weight is on the floor.
But I mean, it's just on his other foot. Like he didn't lose any mass just by picking up a foot. But what he does, he loses some force. Is that what you mean, maybe? I mean, if all it took to lose weight was to lift up a foot, then that's all we'd have to do to get skinny.
Everybody's coming on
I mean, that would be awesome, but I don't think that that's really how it works.
I'm one pound now. What do you do? Put back down the foot to gain some more pounds?
Yeah, I don't think it works that way.
That'd be cool.
It's like you put your foot back down.
So to answer your question, Juan's question was like, where could I put the second law? I liked at the beginning you talked about the pushing force to overpower the friction force. I think that goes with the second law, and it also goes on your word bank. I think you have a word that says unbalanced forces.
That one that
Yeah, I think that's a place where you could talk, like you could add some sentences where you talk about unbalanced forces, and you could talk about some, for example, with the second law. Okay? But you're probably going to have to add some sentences. So maybe like make a little star or something in your rough draft, of where that sentence is, so that you know where to add more sentences. And then I think you have all these all the sentence starters that start with if. These are all about the second law too.
Okay.
Like they would all prompt you to have to talk about the second law. So if you use when you get to any of these if sentences, you're going to have to talk about the relationship between force, mass, and acceleration. Okay? Okay.
I said if Mr. Little carried a heavy backpack while skating, he would go slower. We know this because there's more mass and more weight, which slows down his speed. Which equals more friction, right? Which equals more friction. And makes it harder to overcome your inertia. Because the bigger the mass.
Are you keeping track of like what you still have to get in there? Okay.
If you can't read outside.
At first, Mr. Little is at rest, and when he starts off with his gliding foot, which is putting more force on one leg and pushing. We know this because in the first law,
An object
at rest stays at rest until moved with force. An object in motion stays in motion until stopped. In order to keep himself moving at a constant speed, he has to keep switching between his gliding foot and his pushing foot. For example, if Mr. Little has two stop, if Mr. Little was to stop the motion in his legs, he wouldn't go anywhere and he would slow down because there is more friction on the floor. This shows that because of the more friction on the ground, it causes Mr. Little to slow down. We know this because in Newton's third law of friction is explained to be that there is, the more friction there is, the slower you get.
If Mr. Little stops pushing and just rolls, then the floor ends friction. What did I just say? If Mr. Little stops pushing and just rolls, then the floor adds friction and drags him to the bottom of his skates, which causes him to stop rolling. For example, when Mr. Little had on his roller skates, if there was more friction on the floor, it would cause him to stop, but with less friction, he keeps going because there is nothing to stop him. In addition, when you go to the skating rink and you are used to the polished wood floors in the rink, and when you get off and go into the carpet part, it causes you to fall or stop because there is more friction force. If you want to keep going, you would have to put more force, mass, and acceleration, which helps you keep accelerating.
That's good. I especially like that last part about the skating rink, because you're doing a good example, I think.
Okay, thank you.
Yeah, I think you're going to do good with all these ifs, because they're also ones where you'd have to do an example.
At first, Mr. Little is at rest and pushes against the floor. In order to keep himself moving at a constant speed, he uses his inertia or weight to excel himself. As he is in motion, he is using pushing force to overpower friction. As he pushes off the floor to glide, the floor shoots an equal but opposite force towards him. For example, if a kid kicks a ball, the same force comes back at him and hurts his leg. As he glides through the hallway, his legs are using balance forces, so they have the same velocity. As gravity pulls him to the floor, the ground pushes him up, which is called normal force, or FN. If Mr. Little was carrying a backpack, he would have more mass, if not less mass. As Mr. Little starts to stop, he positions his feet so it causes more friction, until he comes to a rest.
Miss Rodney, here you go.